So for some reason, Armin cannot connect. So let me see. Okay. Hello, Armin. Can you hear us?
Hi everyone, Armin.
Hello. How are you?
Fine, how are you?
Fine, thank you. So I think that it's time to start with the session. Okay, welcome to everyone to the modeling and refactoring session of the ICSI demonstration track. Today we will have three papers. Um, the idea of the presentation is that the authors will have 5 minutes to present the ideas of the paper. Then they will have around 5 more minutes to give some demonstration and show some use case of the tool, show some features and characteristics of the tools. And then we will have around 5 more minutes to discuss and answer some questions. So everyone that has any question can use the chat to write the question, or you can wait until the end of the presentation and make the question by unmuting yourself and ask directly to the author. So let's ask to the first presenter. So Hong Shuai. So Hong Shuai will present a paper. He's from the Hebei University of Science and Technology from China. He will present a tool called Reinstancer, automatically refactoring for instead of pattern matching tool. So, Hong, can you share your screen?
Okay.
Thank.
Can you see my screen?
Yes, we can see it. So, feel free to start whenever you.
Hello, everyone. Greeting from China. I'm Hong Shuai, and so glad to introduce our tool, Reinstancer, automatically refactoring for instance of pattern matching. Since GTK 14, optimized usage of instance of pattern matching are constantly proposed to make the code simpler and safer. GTK 17 proposed another parallel feature to converting multi-branch statements together with pattern matching into switch statements or expressions. However, manually refactoring the pattern matching for the programmers is tedious. Therefore, we developed this refactoring tool. There are three motivating examples from real programmers and OpenJDK. In the first example, we can see that when the object O matches the string type also matches the child sequence type, but the first branch dominates the second branch, and the second branch will not be executed. Sorry. The reinstancer will detect this condition and indicate it. The second example shows the multi-branch statement use of instance of to determine which type of instance of object A, and the no test field and the no test for object A on line 2. So so standalone no test field like arbitrary and arbitrary distinction and invents opportunities for error. Here shows the code refactored by reinstancer. The multi-branch statements take the return statements as a constant execution pattern, and by integrating the no branch, we refactor the multi-branch statements into a switch expression. The second example contains a multi-branch statement to determine the type of object S. When object S matches the triangle type, the calculate area method needs to be called to determine if it greater than the constant 100. Here shows the code refactored by reinstancer to combine pattern matching with judgments on pattern variables to provide a more decorate condition expressions for multi-branch statements. This figure shows the design overview of reinstancer. We enter the Java project. Reinstancer first processes the programmer to generate an abstract syntax tree and then gets all the if statements with pattern matching as judgment condition and the type casting in the statements by visitor pattern. Through control flow analysis and class hierarchy analysis, structure information is collected for multi-branch statements. Pattern analysis, pattern analysis involves the optimization of judgment condition, effectively reduce judgment depth and internal call depth. Finally, pattern analysis reinstance removes redundant casting from the programmer and refactors the multi-branch statements to switch expressions or switch statements. We implement reinstance as the Eclipse plugin. Let's demonstrate this tool. Firstly, we need to check if there is branch domination. When this is happen, reinstancer will give the information about dominated branch. Then select the project you want to refactor and click the tool. This is the refactoring preview. The left side shows the original code and the right side shows the refactoring result. The code is similar to the motivating example. Because the switch expressions are still available for preview, which will have an impact on the refactor format. We evaluation reinstancer in 7 real-world applications. A total 1,972 instances of expression are being refactored. 1,718 explicit casting and 1,342 implicit casting are reduced. A total of 141 multi-branch statements is covered to 109 switch expression and 32 switch expression. The number of reduced circle length of code is reading from 150 to 863, with average of 412 reduced circle length of code. The average psychomatic psychomatic complexity is reduced average of 3.83%, which indicates the reinstancer is generally able to large project. Thanks for watching. Any questions?
Thank you, Hong, for your very nice presentation. So let me ask to the audience if anyone has any kind of question. You can unmute yourself and ask directly to the author. If not, you can write it on the chat. So I will start with one question that I have. I prepared for you, but anyone that has any kind of question, please feel free to ask. So the first question that I have is, how do you validate the refactoring? I mean, you said something in the paper that you ran a test suite, no, that you have previously to validate the quality of the refactoring, to be sure that you didn't change the semantic of the program. So the question is, when you change the code, no, when you refactor the code, how do you check that you didn't change the behavior of the program? Do you use the test suite for that?
We use a so-called mentor tool to check a refactor code. It's a static tool.
Sorry, do you use what?
I say we use a static tool to check the refactor code to get this result.
Okay, a static check-in, let's say. Okay, so in one of the examples that you show, in which you have a char sequence part and you have a string, no, in the second case. So so you have a dominant branch, no, you call it in that sense. So that means that you have dead code, no, so the second sentence will never be executed, no, in the case
Yes.
of the string. Okay, so do you find these kind of cases during your study? I mean, because you mentioned that this can be a way to inject some vulnerabilities, no? It's a potential issue, no, having the dead code. So do you find these kind of issues during your evaluation?
Sorry, uh, we sorry, I haven't.
Yes, I mean,
I saw.
what I mean is that you have different kind of refactoring, no? Different kind of patterns, no? You have one that is the domination pattern analysis, then you have the war pattern analysis, no? Different cases. Do you find dead code in these real cases? I mean, do you find many cases in which you apply the dominant pattern case?
We use a static analyze based on Vala, 然后and through control flow analyze and class hierarchy analyze to get this pattern. And
Okay. Okay. So I think that here we have some comments from the audience. So I don't know if you want to read it, Hong, or I can read it for you. For long blocks of code inside branches, did you preserve the code structure like breaks, identity, and so on? So when you refactor, no, to a switch, for instance, expression or a switch statement, do you preserve the structure of the, let's say, inner block structure?
we to change the when we get this analysis, we to change the syntax tree, 然后syntax tree to change this code.
Okay, but you change the code of the if, let's say, no, of the outer block. Do you also change the syntax, let's say, of the inner block as well, the structure of the inner block as well, or only at one level? Only you refactor the if into a switch?
Yes, only if and to switch.
Okay. Okay. So, for instance, can you hear me? Because I don't know, we have an issue. But Oleg is asking if you use the syntax tree. Did you preserve the comments that aren't normally a part of the syntax tree? Do you preserve the comments of the code, or do you remove it?
Yes.
Okay. Sorry, I don't know why I cannot hear you. Just give me 1 second. Okay, now it's fine. Sorry for that. Okay. I don't know, Oleg, if you get the answer to your question or if you have any other question. Okay. So are you thinking in some future work or extension to your tool currently?
Because the switch expressions are still available for Prevail, I will continue to improve the resistance tensor after the switch expressions are officially released.
Okay. 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 Thank you very much, Hong, for
Thank
your
you.
presentation, and keep online because maybe someone else can ask some more questions, no? And if we still have some time at the end of the session, we can still have an online discussion with the other. Thank you, Juan. So let's now ask to the author of the second paper, Armin Moin. Hello.
Yes. Hi.
Yes. How are you? So can you share your screen?
Sure. I'm going to share it now.
Yes, it's working.
You see it
Perfect.
now? Okay, good.
Yes, I can see.
And you see my first slide, right?
Exact.
Very
so now we have a presentation of the second paper. So let's welcome to Amir Moin from the Technical University of Munich, Germany. He will present a tool called ML Quadrat and Dryot Data, a model-driven engineering tool and low-code platform for smart IoT services. So welcome, Armin.
Thank you very much. Yes, welcome to my presentation. Thank you very much. Actually, I'm going to keep it short because I hope you have already watched my presentation. So I will talk about the motivation and then show you the proposed approach, some screenshots, and then I will be happy to hear the questions. So as you all know, there is currently a lack of data scientists in the job market, and therefore many data analytics and machine learning tasks need to be performed by software developers themselves. Now, a key question here would be how to assist software developers who do not have machine learning knowledge, machine learning background, in creating smart software services that require artificial intelligence, in particular machine learning and big data analytics. Our focus here is on the Internet of Things, IoT, and smart cyber physical systems, CPS domains, because those are the domains that urgently require big data analytics and machine learning due to the huge amount of data that is being generated by the sensors and actuators. And also because software systems are quite complex there. We are dealing with systems of systems, and abstraction, automation are very important there. So that's why we are working on large scale solutions and automated solutions to deal with both software development and data analytics, machine learning. So our research questions here were, can we help software developers create smart IoT services more efficiently, even if they do not possess any deep knowledge and skills in machine learning? And the first research question was the main one. And the second one was, can we then support citizen data scientists and end user programs? So basically people who do not have any computer science background to create smart IoT services. And this was not completely research, or we just explored it and started this direction, and our future work will focus on this more. But the validation was more towards the first question, as mentioned in the paper. The research methods, literature review, implementation, simulation, and testing. We also did some experiments with the prototypes, and also we did an empirical user study, which I will show you the results. So this is the overall approach. Basically, the model-driven software engineering paradigm was deployed, and usually software models, which are abstract artifacts. Out of them, you can generate source code, test cases, documentation, build a script, run script, everything. And the innovation here was also that the machine learning models get generated automatically, and these machine learning models were already synchronized and already integrated with the source code that is being generated. So there was no manual action required. Like basically the user of our tool, the practitioner, creates the software model on an abstract level, and then the source code and the machine learning models are generated automatically out of this model. We followed the domain-specific modeling methodology with full code generation, and we enhanced software models to, as mentioned, to make them capable of generating ML models, training them automatically, deploying them, and retraining them as new data instances arrive. I'm going to skip this for the moment. And so this is a screenshot of our desktop version of ML Quadrat. ML Quadrat is the name of our tool. So here you see the text-based model editor. Usually developers prefer this text-based version. This is a domain-specific language, DSL, and following the syntax of this DSL. And if someone creates a valid model instance that conforms to the meta model, to the syntax, and also it's complete, then one can have a working solution generated automatically out of the software model. So here you see just part of this software model. For instance, this blue part is pertaining to data analytics and machine learning. Like, for instance, here the library that should be used, in this case, scikit-learn, is mentioned. It could have been Keras with TensorFlow backend, for instance. One could even leave it blank, and then the system automatically decides about the best library API for the specific machine learning method that is mentioned here. Labels on, for instance, means we are dealing with labeled, class-labeled data instances. In other words, with supervised machine learning, could have been off, like unsupervised learning, or semi-supervised learning. The machine learning features are mentioned here, and so on. This is another view. So this is the tree-based or form-based model editor. Here we have used the default tree-based model editor of the Eclipse modeling framework, EMF. Our tool is based on the Eclipse modeling framework, EMF. And this textual version has used the Xtext framework for language engineering, which is integrated with EMF. So here is just a kind of graphical view of the same model instance that I just showed you. And then we also developed a web-based version of ML Quadrat, which can be used easily in any web browser, because the desktop version would require installing the Eclipse modeling framework EMF, setting it up, but the web-based version can be just used without any installation easily. Like, one can, for instance, load a sample model, just an example, to see how it works, or this sample model or a modified version of it or a new model instance can be then downloaded on the user's side, on the practitioner's side. A new model instance can be uploaded here. There's a documentation. And by clicking on generate code, if this model instance is valid and complete, then the source code for the Internet of Things service will be generated on the server side. And by clicking on download code, one can download the generated code, which is a zip file. And then for instance, in the case of generating Java and Python code, which is the default in our case study, then the Python code is responsible for the machine learning and data analytics part, and the Java code is responsible for the rest. And those are integrated in the background with each other. So no manual action is needed, and a Maven project is generated, so the user can easily build it using the Apache Maven project and deploy it. This is the view of the prototype that is still being developed. That's towards the direction of the second research question that I showed you about citizen data scientists and end user programmers. So we tried to make it a bit graphical and abstract from the details, but this is still under development, and the validation was not done using this, but using the web-based version with the textual syntax. I'm going to skip the case study. You can see the details in the paper, or we can talk about it in the questions. So this is about now the empirical study that I told you that we conducted it in order to validate it. So we chose 4 different experts, domain experts in software engineering and machine learning, and asked them to use our tool. So basically the web-based version here. And we also offered them the state-of-the-art, so a prior work on which we had built our approach. And also we asked them in a separate experiment to do manual development to solve a specific task. And then it turned out that compared to the state-of-the-art, the productivity leap was 25% on average, whereas compared to manual software development, the productivity leap was 236% on average. The evaluators reported their satisfaction levels compared to prior work as high, medium, and high, and compared to manual development, low, high, medium, and high. And the person who mentioned low meant that the task was rather easy for them. So in case that the task would have been more difficult, like involving different microcontrollers and development with C, for instance, for them, then this person would have also chosen medium or high. Yes, so that was basically a summary of this, and I'm looking forward to your questions. Thank you.
Thank you, Armin. Very nice presentation. The tool looks really, really nice. So again, I will ask to the audience, if you have any question, you can unmute yourself and ask directly to Armin the question, or you can write it on the chat. So I will start with one question. No, I cannot see any question in the chat, so I will start with one of my questions. So your tool tried to integrate, let's say, programming languages, machine learning models, no? And you mentioned that you can train, let's say, the model inside your tool, or you provide that feature, no? So you can train the model there. So basically, do you say to the tool, okay, this is the data that you have to use, this is the architecture of the model, train, no? So that is one of the functionalities that it provides, no? So
exactly.
you have to give the data, no? Okay.
Exactly. So this is basically the comma separated value CSV file that is being provided for this purpose.
Okay. So the tool is able also to keep track of the data. For instance, if you say, okay, these features come from this part of the software, can you save this? What happens now when we are running the tool? Can you save these logs? Because you say that you can, let's say, retrain the model, no, at some point.
Exactly.
So do you keep track of the information of the system?
Yes, very good question. Yes, exactly. That's something that we do in the background. So we always save these data. So for instance, we save pixels, or in the case of TensorFlow, in other formats. And then this text file is also for information purposes for the user. Like the user can see the details of the latest training here in this text file, and of course the user can change it. But in any case, regardless of this, we also keep track of the training, so the latest weights, for instance, of the machine learning model, and we always update that in the background.
So, and in order to retrain the model, do you perform a kind of, let's say, monitoring process when you see that the performance of the model drop? Do you decide to retrain, or it's not something automatic? You do it manually?
Very good question. That's not yet automatized. That's also one of our future work. But at the moment, the user, basically the practitioner, the person who is using this domain-specific language, should use a timer. We also have examples in our online Git repository on GitHub, and they should use this timer. And they can set it, for instance, to 15 minutes, 15 hours, 15 days, 1 month, 1 year, whatever they want. And as this, based on this timer, then in the background, there will be an automated retraining of the machine learning models. And as soon as those new ones are ready, they will be replaced, basically, automatically.
Okay, nice. So I don't know if anyone from the audience has any question. I cannot see any question on the chat, but if you have any question, you can unmute yourself and ask directly to Armin. So as you are using different kind of, let's say, technologies, so you have programming languages, domain-specific languages, machine learning models, what are the kind of, I don't know, challenges and limitation and issues that you find, no, on existing technology, and what was your main contribution, no, of the tool?
Yes. So regarding the challenges, of course, we have not yet automated everything. We have not yet implemented. Like, for instance, we decided to provide 2 modes for our tool. So in one mode, one can simply use the methods, the machine learning methods and model architectures that we already support out of the box For instance, a neural network multi-layer perceptron is one of them. And the list is online in our documentation. But in many cases, practitioners want to use other machine learning methods that are not yet supported, or the new ones that are being developed by the community, by the machine learning community. Or maybe someone already has a pre-trained machine learning model and they want to basically simply bring it here and use it. And therefore, we also support an alternative mode, which is called the black box ML mode. And in that case, somebody can simply just mention which library should be imported from scikit-learn or from Keras, TensorFlow, or whatever. And then they can just mention the path on the file system to the pre-trained ML model. And this way, they can use any arbitrary machine learning method, which is quite flexible, especially for experts users, experts in ML.
Okay.
Exactly. So that's one future direction, for instance, to support more machine learning methods out of the box. Another one would be to support more libraries. Currently, for instance, we don't support PyTorch yet, or non-Python libraries like Veka. We have started some work, but it's not yet finished. Or, for instance, more AutoML, automated machine learning features, like, for instance, hyperparameter optimization for the machine learning model. So in this work that I presented here, the practitioner should either mention the hyperparameters of the machine learning model here, like which activation function in case of neural networks should be used, etc. But we have already done some research towards the direction of AutoML, automated machine learning, where the system automatically chooses the best hyperparameters for this specific task and data set.
Great.
That's also one future direction.
And for the domain-specific language, do you have to provide, let's say, like the compiler or the interpreter and everything of this specific language, or?
Yes, so we have already, that's also a very good point. Yes, that's also one of the future work. Like currently we have supported a number of target platforms for code generation out of the box. Like for instance, we support C code generation for POSIX, like Unix systems, Linux, and we support C for Arduino, for instance. We support Java, Python, so a number of code generators we already have. But for instance, if somebody wants to support a completely new platform or a new communication protocol, like we support HTTP and MQTT. But if somebody wants to support a new one like CoAP, then I mean, we have some basic support for that. But generally, I mean, these are all the directions, possible directions for future work, like supporting new ones. And in order to do that, as you truly mentioned, one should then support the new compiler somehow, like the code generator, and also support it on the meta model or grammar level of the modeling language, basically also. We provided some guidelines in our documentation also for extensions, because it's fully open source. So
Okay, thank you very much, Armin. It was a really nice discussion. Okay, congratulations for the paper. Okay.
Thank you very much.
Okay, I will ask you if you can stop sharing the screen.
Yes,
so
yes, I'm going
we can ask to the third author, Tianshu, if you can share your screen.
I'm not sure if I've stopped it. Okay, now it's stopped. Okay.
Now it's stopped, yes. Thank you, Armin. So Tianshu, if you can share your screen. Yes, we can see. Thank you very much. So let's welcome to Tianshu Bao from the Gisu University from China. So he will present a tool called RM2Doc, a tool for automatic generation of requirements documents from requirement model. So thank you, Tianshu. You can start whenever you want.
Okay. Hello, everyone. I'm Tianshu Bao, come from Guizhou University in China. Today, I'm glad to report our tool, RM2Doc, a tool for automatic generation of requirements documents from requirements models. This presentation consists of 5 sections. Section 1, Introduction. Natural language documents can help stakeholders understand the FAML model, but manual documentation is too costly. Automatic generation is a good solution. Here we summarize some problems of related tools such as they don't include the handling of OCL. To solve these problems, we introduce our tool, M2Doc. Section 2 Overview. M2Doc takes requirements model as input and generates a requirements document. Our requirements model includes a use case diagram, 6 sequence diagrams, system operation contracts, and a conceptual class diagram. M2Doc have 2 features. The first is generating comments for OCL contracts. The second is generating document. In this section, I use an example to show the generation of M2Doc. The first is the natural language comments generation. We can see that M2Doc can generate the detailed natural language comments from the definition, precondition, and post-condition of the contract. M2Doc can generate 5 parts of the document. The first 2 is product functions and user characteristics. They are generated from the use case diagram. This is a use case description. Use case diagram generates the basic information, and the system sequence diagram generates the full description of the use case. System operation description is generated from the system operation contract. Analysis is generated from the conceptual class diagram. In section 4, evaluation, the evaluation was conducted in these 4 case studies. Out of 1,038 system operation, 1,033 system operation were successfully modeled. 1,038 and 30 generate operation description. Therefore, the total success rate is 95.02%. Conclusion. First, the information from the UML diagram is presented in tabular form in the document. Second, the system sequence diagram generates the flow description of the use case. Third, OCL contracts are translated into natural language. Last, 4 case studies evaluated the capability of M2Doc. There is some future work to improve our tool. Our case tool M2Doc can be downloaded from our website. I will use Kukumi as an example to demonstrate the 2 features of our tool. I already opened the Kukumi example here. As we see, the required model is divided into 2 parts. The first is graphical part. The second is the textual model. This is the use case diagram. This is the system sequence diagram of uses process cell. This is the conceptual class diagram. For each system operation in the system sequence diagram, there is a contract in the textual model. This is the contract of system operation enter item. It includes signature, definition, precondition, and postcondition. Okay, let's generate the comments for the contract. Right click, choose ARM2Doc, advanced features, generate NL contract. A moment. Enter item. Oh, 这个let me try the document generation. Oh, okay. That word. Okay. The document is generated. Let's open it and have a look. This is product function section. This is user characteristics. This is requires function. It includes two parts: use case and system operation. Use case, system operation. This is entity analysis. Okay, let me see the use case process cell. The basic path is generated from the system sequence diagram. Click here to see the involved actor. Cacher. Click to return the use case. Click enter item to see the sys operation description. This is the system operation description of enter item. It includes input, output type, definition, precondition, and postconditions. Click to see the entity item. This is the entity item analysis. It includes attribute relationship. It also can see the related entity. This is the product catalog. Okay, that's all. Oh, thank you.
Thank you very much, Tianshu, for the very nice presentation. We already have two questions from Alessio. I don't know, Alessio, if you want to ask by yourself or if you want, I can read it as you wish.
Okay. Oh, that works.
Okay. Okay. Yes.
Yeah. Thanks a lot for the presentation. So I was wondering, how does the tool perform on incomplete or syntactically inaccurate models? Like, does it try to generate the form anyway, or the tabular form anyway, or it crashes?
So what do you mean, Alessio? Is basically if
For
the model
example,
is not correct or is incomplete?
yeah, it's
What will
incomplete,
happen?
does have a dangling link, or for example, the sequence diagram is not consistent with the class diagram. If you have this type of problems in your model, does the generation try to generate, the generation system try to generate an incomplete description, or does it just say your model has error and I cannot generate anything? Did you get the meaning of the question? Do you think it's clear?
Tianshu,
No.
do you understand the question? I mean, if the model is not correct or incomplete, no, can you still generate some description, or no, or the tool will stop and say, no, your model is not correct?
My model is not complete.
Exact. If the model is not complete,
Okay.
can you
Okay.
still generate a description, natural language description document, or no?
Yes, it can. It M2Doc can generate the description, the document. If my model is not complete, the information in the document is not complete too. But if you complete your model, the document, the generated, you generate your document again. The document is complete.
Okay, but you still can generate, let's say, a partial requirement document from a partial requirement model. You still can generate something. Okay, this is what I
Yes,
understood. No.
Implementations. Can you hear me?
Yes, we can hear you.
Okay. The correctness about the required model that is guaranteed by ARM2PT. That is work is already published in EXA 19. So that work, checking work is published by that tools. So in these tools, we only translate the required model into the documentation. So we don't check there is any errors or any inconsistency. So the functionality about the checking is belong to that part of work.
But so you assume that the model is correct.
Is correct. Yes,
Okay,
that's
so
true.
if it is not correct, what does it happen? Does it generate something?
So
if the model is not correct, I have an incomplete or incorrect generation of the table, or just an error message.
yeah, as the Tianshu just told, if the model is inconsistency, we still can generate some document, but that document contains some
Thank you.
the errors. So it will be consistency.
Perfect.
Thank
Perfect.
you.
So, and the second question,
Since
Alessio.
the network.
Yeah. Sorry, Jonan. Yes, you can continue.
I already finished. I just mentioned the network is not stable for my part. As a very high delay.
Okay, no problem.
Okay, you can continue. Okay.
Yes, and for the second question, Alessio, I think that you were talking about, okay, this tool help you to go from the model to the requirement documentation. So how difficult or how easy could be to go from the other way around, no? From the documentation, natural language description to the requirement model, no? And I think that okay, yes, that is your question, no?
Yes.
Okay. So I don't know if you can do like a reverse engineering, let's say, from the natural language description to the model, or it's out of the scope of your research.
That's our future works. We try
Okay.
to translate the such as the natural language requirements into a requirement model. So that's our future work, and I think that is not future. We just undergoing this kind of work. We
Ongoing.
try to translate the stories, for example, user stories, and also we have the try to translate SRS documents into the requirement models. For example, use case diagram, such as, but not is that kind of work is not published yet.
Okay.
I hope we will publish that next year.
Okay, and the other paper that you mentioned from ICSI 19 is basically you translate the model into source code, no?
Prototype, yes, source code.
Okay. Okay, so something that that I was wondering. So if anyone from the audience or Alessio, if you have any other question, please feel free to ask. We still have more minutes. So I was wondering, I was checking the examples that you show during the presentation and in the paper, and the sentences in the natural language are really readable, no? So you have correct nouns, correct adjectives, correct verbs, no? So how do you manage that? I mean, where do you get this information? When you take the use case, how can you generate a very nice natural language sentence, no? Do you know what I mean? Do you use some kind of library, or how do you generate the natural language sentences?
Yes. Andrew can maybe answer this question if you can.
For
Do
instance,
you
in
understand the questions?
I mean, the question is basically, for instance, in the user characteristics, no, when you have a description of the actors, for instance, no, in the paper, I don't know, you have a store manager. The store manager is responsible for procurement and price setting of items and opening or closing the store or things like that, no? Where do you get these descriptions from? I mean, is this part of comments of the model and you put it in the requirement model, or how do you generate these descriptions? No?
Do you get the point?
A little, just a little.
Okay, you can try answer some part of the question. If
Okay.
not, I will.
Okay. Other question is basically at the end of your paper, you measure or you talk about the correctness of the generation. How do you know that the translation or the generation, no, was correct or not? How do you do that? Manually? Do you inspect manually the document and say that the translation was correct or not?
Did you get the point? Okay,
Okay.
let me give some information for the previous question. Okay,
Yes.
the previous one, how to generate the descriptions from the models. Usually they have we generation the description from two parts of things. First, all the information comes from the model itself. This is first part, And also, we both know the model have less informations we wanted, so we have some tags there. For example, we give some description, actual description for the use cases. So we directed generation the information from the tags and as well as the information from the models. So we have two part for the input. And also for the result, you just mentioned, well, how did you generate some kind of very strategy or very formal description? Because we providing lots of templates. We have some predefined templates there.
Okay.
So we no matter what kind of the model you provided, we go through, we read the information from the model and go through fill the information into the template, and then we can get the ISRS document that is conform the standard IEEE. I think that is 830.
Yes.
So that is the technical the ideas behind that. For the technical part, we using X test. The X-Text is some kind of the DSL for the Java languages that providing it engines. So we use that to implement our template. And then we read the information from our EMF model. The EMF model, we're using the EMF the R model. So that things is happened there. So this is the previous question. I think I answered part of that.
Yeah, thank you
The
very
next
much.
question you just mentioned is, so how to check the correctness about the generation the success rate.
Yes.
So we have some ground truth for that, and then we manually check that by the human. So that involves some human evaluation there. So different we have also give the human have some evaluation standards. For example,
Okay.
we give the score from the -5 to the 5, and then we let them to make the score to that they generated. After that, we get the final score.
Okay,
So
perfect.
that is our basic.
Perfect. Thank you very, very much for your answer. Now, Alessio is asking about if the source code is available, and I think that Tianshu is answering. So I think that, okay, you already have some people that is interested to use your tool. So we still have 2 more minutes. I don't know if you want to mention some future work, or okay, you already mentioned that you are trying to go from requirement documents to requirement models. I don't know if you want to add something else before closing the session. If you can, Tianshu, can you put the link of the tool? So Alessio can access to the tool and use
Do that for her, for him.
with him. Okay.
Yes, this is the M2P. Did you see my URL? I already sent the message.
Okay.
It's
Okay.
Not,
So I think that it's time to.
Yes, it's here.
Okay. There
Thanks
it is.
for Silos. You use the link there. Yes, all the code. I think the current moment we don't put the source code there, but we have the binary plugin. You can easily install that into any version of the Eclipse, and also
Okay.
all the case study is available there. So this set, the case study, as well as the tools is all available online. You can, if you like, you can download them, and if you have any problem in the future, you can contact us.
Yes.
Thanks very much.
Okay. Thank you very much to everyone. And the session is going to end. So it was very nice. And okay, see you around.
Okay, thank you.
Thank you.